Hello everyone, it's a pleasure to be invited to this great talk today. I want to show you how we can increase the efficiency of chemical research by catalyzing the adoption of automation. So I'm focused in finding that next world-changing discovery. You've already heard of some really critical problems in pharmaceuticals that we want to try and find those molecules for. And if we're thinking of those next generation discoveries, be it in pharmaceuticals, be it in battery technology that will help change the world, they are actually just one success story of over up to 20,000 different molecules screened in this entire process. And this isn't cheap. It comes at the cost of over $2 billion of research time, and it can also take over 10 years to find that one special molecule. And ultimately, we must ask ourselves, why is it so difficult right now? Well, the answer, unfortunately, comes down to the chemical space is just huge. The permutations you can take elements from the periodic table and combine them into molecules is unfathomably large. Imagine it instead of as if it's like grains of sand on the beach, and I've asked you all to please go and dig through all the beaches of the world to find me those two diamonds that sit there one at a time. Now I'd try and think, how can we do this more successfully? How can we ensure that we can get a better answer quicker? And I'd hope we can all agree a standardized approach is a good start if we try and map each quadrant out and take it one at a time. I think it's critical that as we search through that space, it's reproducible. So if I'm focusing in this spot and I can't find anything of value, I can go onwards and move forward and tell you all, please don't look in that space anymore. There is nothing of value. We can save ourselves some time. It has to be scalable. I can't spend my entire budget and the world's budget searching this tiny little square and then see that there's the rest of the beach to go and explore. We have to be cost effective in our approach. And the last one I'll put towards, if I asked you to go and do this and I offered you a small spade or a giant yellow JCB digger, you'd probably choose the automated mechanized approach because it's going to save you time, it's going to save you money, and we'll hopefully get to the answer quicker. And the combination of these four elements is what I propose will solve our problems in chemistry. And it'll be a step change. It'll be called CATALYSE. That's the name of this program. It's the Center for Automated Technologies to Advance Laboratory Yields, Standards, and Experiments. Ultimately, it's a shared space for state-of-the-art automated equipment. From an experimental perspective, we're outsourcing the mechanical execution of our experiments to machines. Very straightforward. You or I would submit a digital experiment, and then we'd, as if we're sending an email and adding an attachment, and then a week later we'd receive standardized, reproducible results that we know I get those results, you could get it the same, and we know how to explore this space. Critically, this is so important as we enter this new AI space, as we're going to start creating very high quality, experimentally validated data sets. So of course we have those 4 or 5 very successful reactions you've done, congratulations, but also the hundreds of failed reactions that you've also done that we're not capturing and we're not storing anywhere. We need to ensure that they've been done correctly, and then we can keep them to one side. And the next time a user asks, what have you done about these conditions? We can go to our pot and say, we've already tried that. It's not worth exploring that space. Financially, this is a really solid idea because automated workflows will always outcompete the manual work that a chemist that I was, as myself, the past 10 years, have been redundantly executing across the country once at a time. We can start transforming our wasted capacity into a coordinated, data-driven asset. And this is going to be very powerful both nationally and internationally. We can start linking academic, industrial, and government research labs from the top of Glasgow to the bottom of London with a common digital backbone. We can start training our next generation of researchers in this more advanced, kind of logical way of predicting and conducting experiments. And ultimately, we can go towards increasing the R&D workflows in our labs by 100-fold to find those next generation of medicines and materials. With that, I'd like to say thank you very much. If this interests you, I'm speaking across the hall at 5 to 5 later on today. Thank you very much.